Alrighty, folks, here are the rest of your notes. The slope of a horizontal tangent line, as we know, is going to be, that's right, it's 0. Right, if you think about a horizontal line, the slope is always 0, okay? When does the function have a horizontal tangent line? So what that means is we need to figure out the slope of this line first and then see if it has a slope of 0, okay? So I need to figure out my derivative function, which is going to be 2x minus 6, right? And then I figure out where that equals 0. Okay, so take a second, solve that out, and then we will keep going. All right, hopefully you got when x equals 3. All right, try the next one for me. Pause the video, come back, and it'll have the answer. All right, hopefully you remembered your unit circles. So you're figuring out where cosine of x equals 1/2, which is where x equals pi over 3 and 5 pi over 3. All right, the next one is going to be finding the equation of the tangent line of f of x equals x squared when x equals -2. The first thing that you want to do is actually figure out what the coordinate is that matches this. So in this case, I'm actually going to plug in -2 for f of x because I want to see the matching y value at the original function. Okay, so the coordinate is -2, 4. Now I need to find the slope of my tangent line. How do you do that? That is right, you take the derivative, so it's 2x, and then you got to plug in that's right, the -2. So our slope is going to be, that's a +2, sorry, is going to be -4, okay? Make a note for yourself that this is the slope of your function. Now, if you wanted to write the equation of it, you could either do it in point slope form, which is much faster because it's just y plus 2 equals -4 times x minus 4. You're welcome. All right, so that is your equation. Or if you want to use slope-intercept form, you could just do y equals mx plus b and do the same thing. Y equals -4 times -2 plus b. 4 equals 8 plus b. So b would equal -4. So you could also write it as y equals -4x minus 4. So either of those equations would work. I think point slope form is a little bit easier and you don't have to do a whole lot. Try the next one for me, please. All right, folks, hopefully you got either y minus 0 equals 3 times x minus 1 or y equals 3x minus 3. So if you forgot to plug in the 1 to get the point, make sure you do that into the original equation, right? And then you need to figure out the derivative, plug in the 1, get your slope, and so on. All right, we're moving. So the last section here is talking about a position function. So you may remember either from physics or pre-calc or algebra 2, a free-falling object, if it's thrown up straight in the air, is going to be either s of t equals -16 t squared plus v sub 0 t plus s sub 0, or the initial value changes. So the first one is going to be for feet per second squared, and the second one is for meters per second squared. You are eventually going to have to know both of those formulas, but the key, the really important pieces is that s sub 0 is the initial position, so in the initial height usually, v sub 0 is the initial velocity. So sometimes it's going to be negative because it's going down, and most of the time it's going to be positive if it's being thrown up, okay? Not like throw up, like it's being thrown up in the air. And then s of t is the height, okay? In this case, it says at time t equals 0, a diver jumps from a platform diving board that is 32 feet above water. The position of the diver is given by that equation where s is measured in feet and t is measured in seconds. So remember, we're going to be using this equation, right? It says, when does the diver hit the water? So what I want you to think about is, this is just like a pre-calc or algebra 2 question where you're thinking about what the height is when the diver hits the water. So in this case, our s of t is going to just equal 0. So really this question is asking you to solve for t when the height is 0. And you shouldn't have to plug that into your calculator because it is factorable. You can factor in -16 And we have t squared minus t minus 2 equals 0. T minus 2, t plus 1. So we end up with t equals 2 and t equals negative 1. Hopefully it makes sense that we're only keeping the t equals 2 because you can't have negative seconds. So it takes 2 seconds. Now, then it says, what is the diver's velocity at impact? If you are not in physics or you've never heard of velocity, it's basically your speed with direction, okay? When you're talking about a height function, what happens is you can figure out velocity by actually taking the derivative of the height function. So s of t, or s prime of t, is going to be negative 32t plus 16, because we just took the derivative. Now it's saying, what is the diver's velocity at impact? So to plug in, think about how long it took for him to get to the impact, and it took 2 seconds. So you're looking at the previous question to figure out what you're plugging in this case. Okay, and you end up with, weirdly, a negative 48 feet per second. Make sure you're given units here, because it's heading in the downward direction. So that's why it's negative. It's falling, basically, okay? All right, the next question is talking about Mr. Fleet. He is balancing on top of a flagpole, because he likes to do that on the side, apparently. He is in front of the school and drops a billiard ball off his foot that is level with the top of the flagpole. How many meters tall is the flagpole if it takes 1.6 seconds to hit the ground? So with this kind of question, I always draw a picture, because what it's really doing is saying Mr. Fleet's up here, he's dropping the object, it takes 1.6 seconds for it to hit the ground, okay? And they want to know how tall the object is. Now, in order to do that, what you should recognize is that your initial velocity, aka your initial slope, is going to be what? In this case, not always, but when it's talking about an object falling from an initial height like this, the initial velocity is 0, right? Because your slope is 0. So what you'd want to do is take your derivative of your, figure out what your initial velocity is. In this case, it's going to be 0, and set it equal to your position equation. So our position equation, when it comes in terms of meters, because they're talking about meters tall, is your negative 4.9 t squared plus v sub 0 of t plus s of 0, okay? So if your initial velocity is 0, you could plug that into the equation. So I'd have negative 4.9 t squared plus nothing, right? Because the initial velocity is 0, plus my initial height. This is my initial height. It's plus x, okay? And we want to figure out when that equals 0, because it says it's going to take 1.6 seconds for it to hit the ground. Remember, our ground is a height of 0. So what can I plug in for t? That is right. You can plug in 1.6. Okay. And then now solve for x. And you get x equals 12.5 meters. All right, the next one is kind of a combo of all the things that we're learning in terms of an application. But what I would like for you to do is try to figure out the initial height and the initial velocity. So do that first based off of the given question. All right, folks, so your initial velocity should have been the 64. Initial height is the 50. So if you were to write the equation for that, it should look like s of t equals negative 16t squared plus 64t plus 50. Okay, so to figure out your maximum height, what you can think about is, what is the derivative at a max or a min? Yep, that is 0, although I totally skipped the letter A. How many seconds does it take for the object to reach its maximum height? I'm going to do it down here. So for it to reach its maximum height, again, that height at the slope is going to be 0. So you can take your derivative, which is going to be negative 32t plus 64, right? that's going to have to equal 0 if you're at a max. So the t is going to be 2 seconds if you solve for that. And then to figure out the actual maximum height, you could just take your original function and plug in the 2 seconds. Okay, and you end up with 114 feet. For letter C, it says how long does it take the ball to reach the ground? So think about what that means. Your height is 0, right? So you're actually taking your original function this time and setting it equal to 0, not the derivative, because now they're figuring out your original height is 0. I'm going to have you take a few minutes and solve that out. If you want to use your graphing calculator, great. Quadratic formula works. It's unfortunately not factorable. So pause the video, come back to it, and I'll have your answer. All right, so I got 4.7 seconds. I used the quadratic formula to do this out. I'm not going to show that because at this point you should know it. But for letter D, this is where it gets more into the calculus again. So letter D, how fast was the ball traveling after 4.5 seconds? Speed is going to be, or velocity, is going to be your derivative function. So it says how fast after 4.5 seconds. So all you have to do is take your derivative function and plug in 4.5 seconds. And so you get negative 144 plus 64. So you get negative 80 feet per second, which again is going down because it's a ball being dropped. And then letter E, S prime of what, you think? All right, is 4.7 because it says how fast, aka the derivative, was the ball traveling when it hit the ground, meaning when it hit the ground was t equals 4.7 seconds. So that's why you're plugging in 4.7 here. You end up with negative 85 feet per second. You can do that out if you would like to see how it works. And then letter F is what is the average velocity between 1 and 2 seconds? So the average velocity is the change in position over the change in time. So the change in position over the change in time. I want you to think about what that means for a second. Okay, so velocity is actually going to be distance over time, which is kind of weird for us because we're used to velocity being the derivative. But average velocity is actually going to be, in this case, s of 1 minus s of 2 over the time change, meaning 1 minus 2. So you're actually plugging in the 1 and 2 for the original function, subtracting them, and then dividing by your negative 1, okay? Or you could flip it around and that works too. So if I plug in 2 seconds to my original and plug in 1 second, I end up with s of 1 is 98 and s of 2 is 114. So again, you could go in the other direction and get both positives, but it's 98 minus 114 divided by negative 1, so you actually get 16. And it's going to be, is this feet per second? Yes, feet per second. Okay, so try the same thing for G, the average velocity the whole time the ball is in the air. Okay, so if you didn't recognize this before, you're really trying to figure out the average velocity, meaning the time it takes after you're looking at the distance it travels. So if you actually want to do the math for that, all you need to do is figure out s of 4.7 minus s of 0 over 4.7 minus 0, because that's the time it took to reach the ground, which, if you think about it, is the whole time it took from the initial height all the way to the ground. Okay, so in this case, you can actually just do s of 4.7, which, if you think about it, is going to be 0, right, because it's the ground, minus the initial height, because if you plug in 0, you get the initial height, over 4.7. So you end up with negative 50 divided by 4.7, which is negative 10.64. 4 feet per second. All right, the last two questions are going to be trying to figure out the velocity, aka the derivative, and how that looks. Okay, so think about your slope and what that means. Just be careful because this is miles per hour and the other one is going to be in miles per hour as well. So if we figure out the slope of each of these, that's going to be the easiest way to calculate what the derivative looks like. Okay, so if you calculate your slope here, you can do rise over run if you want to, which is 1, okay? This is going to be in minutes, because this is miles per hour. Just be careful that you have to calculate how many minutes that would be if it's miles per hour. So it's actually 1 minute is 60 seconds, or 60 minutes is 1 hour, because this is miles per hour. Miles per hour. So just convert that. So really between 0 and 4 seconds is going to be 60 minutes. Okay, then it actually jumps down, because what's the derivative of this, aka the slope? It's 0. So between 4 and 8, it's 0. And then it jumps up again. So between 8 and 10, that has a slope of 1/2, which if you do 1/2 times 60 minutes, that's 30 minutes. So it's going to be that. So it almost does like a little jump, okay? If you notice on the next graph, now they're having you go from velocity to distance, and you can probably see it's almost exactly the same thing. So if it's 60 that you're going to convert to minutes and it's in hours, you're going to do 60 over 60. So between 1 and 4, your slope is going to be 1. So you're doing rise over run here. Okay, between 4 and 7, it's going to be 0, which means it's a flat line. So 4 and 7. And then between 7 and 10, you're at 30, which again, you can divide by 60 to get your slope here. So it's going to be rise over run, so 1 over 2. So that is your antiderivative. You're going backwards a little bit, okay? So folks, that was your homework for tonight. I hope you enjoy the rest of your day, and I will see you soon.